Okay, so for this video, we're going to take two examples of rational inequalities. I picked them out of your homework because some of them give people a little bit of trouble, and I thought I would cover these. So the first one, we just have a rational inequality. It's already set up greater than or equal to 0, which is nice. So let's just go ahead and work it. Okay, so I'm going to start with writing it down. We have 6 minus 2x. Just need to write it a little bit bigger so I can see it. Set greater than or equal to 0. So our first step is to find the boundary points. So when you have a fraction like this, you're just going to set the top and the bottom equal to 0 to find your boundary points. So let's see, for the top one, if I set that equal to 0 and solve, let's see, that would give me 6 equals 2x. We would get x equals 3. Okay, that's for the top. And then if you set the bottom equal to 0, you would get, let's see, x equals negative 2/5. These are our two boundary points. Okay, now that we've done this, this is what we're going to plot on our number line. So let's make a number line. We have negative 2/5 and 3. Okay, this is where we need to decide whether or not we're going to do straight or dotted lines. This is the part that most people miss when they're working these rational inequality problems. Okay, if you look, our problem right here is a greater than or equal to 0 problem. So normally when we see equal to 0, we know to draw a straight line. So for the numerator, which 3 is what made it 0, we can draw a straight line. Okay, that's straight or dotted depends on whatever sign you have. But, and this is what's different, for the denominator, whatever number makes the denominator 0, which in this case is negative 2/5, it can never be a straight line. It has to be dotted or an open dot. The reason is negative 2/5 is the number when it plugs into my polynomial or my rational function, it makes the denominator 0. And we know that the denominator of a fraction can never, ever, ever be 0. So negative 2/5 can never, ever, ever be a part of the solution. So I cleaned this up a little bit, and we have everything set up. Now we're ready to look at our number line. Okay, we're going to test regions. Let's see, we have 3 different intervals. We need to test for each interval. Pick a value of x. So here we first have anything to the left or less than negative 2/5. I'm going to pick negative 1. You're going to plug it into our polynomial. And let me recopy it down just so we can see it right here over by our number line. And this is what we're going to plug into. So we take negative 1, we plug it into our polynomial. Remember, we're only worried about whether it's positive or negative. So if I plug negative 1 in, I get 6. And then minus 2 times negative 1 is 6 plus 2. That's positive. Denominator, 5 times negative 1 is negative. 5 plus 2 is negative. So we have positive divided by negative gives me a negative number. So that whole interval is negative. Let's move to the next one. Let's see. In between negative 2/5 and 3, I'm going to pick 0. If I plug 0 in, I get 6 minus 2 times 0 is 6. And on the denominator, 5 times 0 is 0 plus 2. That gives me positive divided by positive is positive. So that whole interval is positive. And finally, let's pick something larger than 3, like 4. If we plug 4 in, we get 6 minus 2 times 4 is 6 minus 8. It's negative. And then 5 times 4 is 20 plus 2 is positive. Negative divided by positive is negative. So we have our number line finished. Now we can figure out what the answer is. I'm looking for where the polynomial is greater than or equal to 0. So I come over here. That is positive. Greater than 0 is positive. So here's my interval in the middle. So when I write the answer, I want to write all of the x values that give me a positive value. So my answer would be, I go from negative 2/5 to 3. That's why they call these boundary points or interval endpoints. And then our question is whether we have parentheses or brackets. Remember, the dotted line means a parenthesis, and a straight line means a bracket. So So this is my final answer. Okay, for the second example, if you notice this rational is set greater than or equal to x, and that is different than the other ones we've had. Before we can work it, we have to have 0 on the right side. So I wanted to pull this one out of the homework and work it for you. But before we start, I do want to make one quick change. And I want to change the problem to be a less than or equal to x. I'm just changing it because the last problem we did in this video was a greater than, so I thought I'd change this to be a less than. So let's work it from here. Now if you notice, you've got the x, we have to have a 0. So in order to do this, you have to subtract x to the other side. So let's do that. We have x squared minus 40. Subtract x to the other side, so that would be minus x. There you go. Okay, now before we can do any kind of boundary points or line sign charts, we have to get this into one fraction. So that requires us to get a common denominator. So I need to convert x to a common denominator. So let's see. Our denominator would be, what, x plus 8? That would be x. And I want to make that over x plus 8. And remember how that works? If I put x plus 8 in the denominator, I have to put it in the numerator also. There you go. Now they have common denominators, and we can combine them into one fraction. So in the top, let's see, we have x squared minus 40. Right, we want to, this minus right here, we want to distribute the x through, so that would be negative x times x, x squared. Negative x plus 8 is minus 8x. That is all over x plus 8, less than or equal to 0. We're almost there. We can subtract out x squared minus x squared. That gives us negative 40 minus 8x equals, over 8x plus 8 is less than or equal to 0. Okay, so now it just took some work. That's why I wanted to work this one, some steps you had to do before. But now that we have the fraction less than or equal to 0, we can work it like normal. I do want to say that when we solve for our boundary points, if you notice the numerator can still be factored. I personally like to have it in factored form because it makes it a little bit easier. You don't have to do it, but I'm going to take it one more step and I'm going to factor the top. I can factor out a negative 8, and that leaves 5 plus x. It's just, once again, you can use either one of these to help you. All right, so now we can find our boundary points. Now remember, the boundary points with a fraction is you have to set the top equal to 0. The negative 8 is just a constant, so it has nothing to do with it. But to find your boundary point at the top, if you set that equal to 0, you would get x equals negative 5. I'm going to circle that. And in the bottom, if you set that equal to 0, you would get x equals negative 8. Okay, those are my two boundary points. Let's see. Oops, I'll do that. That's boundary points. And now we are ready. We can plot these onto our number line. I'm going to recopy this just so we have it up top because we're about to start doing our sign chart. Just kind of nice to have it. So there's my polynomial. Let's do our sign chart. Okay, plotting them. We have two boundary points. We have negative 8 and negative 5. We have to decide about straight or dotted lines. Now remember, we were looking for less than or equal to 0. So the numerator, which gave us x equals negative 5, because it could be equal to, we can draw a straight line. But remember what I've said, the number that makes the denominator 0 can never, ever at any time be a part of the solution. So that is a dotted line. So remember, the denominator always is dotted, always, always, always. Okay, so now we're ready. Let's test a value out of each interval. Let's start to the left. Anything in this interval to the left of negative 8, I'll pick negative 10. We plug it into our rational function right up here. So we have, let's see, negative 8 is negative. Remember, we're only concerned about whether this thing is positive or negative. So we have negative 8. 5 plus negative 10 is negative 5. And then on the bottom, negative 10 plus 8 is still negative. So if you think about it, we have in the numerator, negative times negative gives you a positive. Right, divided by negative. Positive divided by negative is negative. Okay, let's do our second one. Something between negative 8 and negative 5. I'll pick negative 6. Plug it in, we get negative 8. 5 plus negative 6 is negative 1. And the denominator, negative 6 plus 8 is positive. So 2 negatives in the top give you positive over positive. So we have a positive. And finally, something larger than negative 5. You can pick anything you want to. I'm going to pick 0. So that's larger. And we have, let's see, negative 8. 5 plus 0 is positive. And 0 plus 8 is positive. So in the numerator, we have negative times positive. It's negative. Positive in the denominator. Negative divided by positive is negative. Okay, now we're ready to find our solution. So we are trying to search where is this rational function less than or equal to 0. Less than or equal to 0 means negative. So if we come to our number line, we have 2 intervals that give us negative numbers. So our answer, let's see, will be this interval, right? Anything from negative infinity to negative 8, and then we'll pick back up at negative 5 to infinity. So the way we write the answer will be, let's see, negative infinity to negative 8. A dotted line means a parenthesis. And then we'll pick back up at negative 5, a bracket to infinity. The bracket is because we had a straight line. And here's my answer.